everybody, welcome to my channel. Today we have a very good problem for you guys called group anagrams. So let's quickly read the problem statement, right? So it says given an array of strings, right? Group the anagrams together. You can return the answer in any order, right? Very interesting problem statement, very simple and concise. So we're simply given an array of strings, right? And we need to group the anagrams together. So I think this example is going to help solidify the ask, right? See, we're given a bunch of strings, right? And then we need to return the strings, right? A list of lists, right? Which groups pretty much the anagrams together, right? So words are anagrams of each other if they contain the same characters with the same frequency, right? So they contain the same amount of characters, right? The same characters are present, right? And with the same frequency, right? So pretty much, you could kind of think of it, right? So we have an E here, we have an E here as well, right? We have an A here, we have an A there as well, and a T and another T here as well, right? So those words are anagrams, right? Pretty much you got to think of it, right? A different arrangement of the letter of the characters that we have, right? So the words they contain the same characters with the same amount of frequency, right? Different permutation, right, of the characters. That's pretty much what those anagrams mean, right? Words are anagrams or permutation. Two words are anagrams of each other if they contain the right permutation, right? Hopefully you guys understood, right? So how they ended up with those answers, right? So you can see that those two words are anagrams of each other, right? See, eat, and eat and tea, right? They're anagrams, right? You can see them here, and we have this 8 right there, right? Which contains the same amount of characters, the same frequency as well, right? So you can see they're present as well. That's why they're grouped together. And this one's by itself, right? There's no other words that have the same characters with the same frequency, right? And those two matches, right? Because they have the same characters, right? The same frequency. We have 1A, 1A, 1T, 1T, 1A, 1A, right? So you can see they have exactly the same amount of characters, same frequency, right? No more, no less, right? Which is very important, right? Just to be exactly the same, right? Yeah, so we're given this empty string and a string, right? So how do we go ahead and solve this, guys? That's kind of what we need to come up with. What is the solution that we need to come up with, right? Okay, so how do we group different words together? It's kind of the difficult task that we're asked, right? So we could tell if they're anagrams or not, right? Right? Because we said that if they contain the same characters with the same frequency, right? For each character, right? So there's one E here, there needs to be one E here as well, right? If there's an extra E, that means that they're not anagrams, right? Because there's one extra character and they're anagrams with each other, right? And anagrams, I told you guys, different permutation, different arrangement of the characters. Okay, so how can we group them, right? So we have this eat here, right? And we have this T here, right? So how can we group them, right? Right? So an easy way of doing it, right, is to have some sort of a uniform way to tell if two strings are anagrams, right? So we could conform them, right? We could rearrange the different characters in each string, right, in a systematic way, a uniform way that is the same for each anagram, right? And also, for example, eat and tea, we know they're anagrams, right? The uniform way that I'm thinking, right, is to maybe think about sorting them, right? Because we know that they're different arrangement of the same characters, right? The same characters, but arranged in different permutation, different ways, right? So how about we do it for that? For each character, right, we have this protocol that we have, right? We just sort all the characters, right? And we could see that after we do the sorting of the characters, right, and the string, right, they end up having the same string, guys, right, after the sorting, right? And that's why we could quickly tell, right, if they're anagrams or not, right? And by doing that, we can store them, right? We can group them and store them in pretty easily, right? So what I'm thinking is to, so we need to store them and group them, right? So perfect data structure for that is going to be the hash map that's going to be useful, right? So the key, right, would be the way that we came up with, right, which is the sorting, right? The rearrangement of the letter of the characters, right? So that we know every time, right? Which every time we get a word, right, we sort it, right? If it has the same. If the sorted string, right, the sorted arrangement of the characters, right, all the same with another string, then we know that those strings, they're anagrams of each other, right? So we can easily tell, right? So sorted version, right? Sorted version of the string, right? Okay. And the value, right, will be the list that we're going to be maintaining, list of anagrams, right? As simple as that, right? So we have a uniform way, right, to easily tell if two strings are anagrams of each other now, right? We could easily add them, right, to the list, right? Pretty simple, right? So let's quickly go ahead with the algorithm, how I was going to do it, right? So we said that we're going to use, so we would loop through, right? We would sort the characters in there, right? For sorting, we have AET, right? Just like we did up top. And then we go ahead and add it onto our thing, right? Follow me? We have T here, right? Then we know after sorting is AET, which maps to the same thing here, right? T, right? And then we do 10, which is ANT. So after doing the sorting, right? So we're doing the sorting. Okay, what's next for us? 10. We see 8, which is the same thing as AET, right? And then the next one is NAT, right? Which maps to this one, right? And then we have this one by itself, which maps to, I'm tripping, it's ABT, which maps to that, right? Which is by itself like that, right? So, we have a uniform way of, finding out, we sort it, right? Sort the strings, we get the sorted version of the strings, right? Because we could easily map the different anagrams, right? We could easily group them by that, right? That's what they're gonna have in common, right? Is the sorted version, right? So after that, we just group them by this thing. After that, we just group them by this thing, and then we're in good shape, right? We can return the list of values, right? This is a pretty good solution. It's not too bad actually. We go and we have n, right? And k log k because of the sorting, right? We have n strings, and we have doing this amount of work to do the sorting, right? It's not too bad, right? But we could optimize it a little bit more, right? So we know that another thing that they have in common, right? Whereas there are another thing that anagrams are gonna have in common, right? Is the frequency map, right? So let's say we were to take the frequency map of of each string, right? So by frequency map, right? I would pretty much get the count of each character, right? And some sort of an array data structure, right? If it's an array, we count how many times we've seen each character, right? Each letter in the alphabet, right? That's how we would do it, right? So we would get the map, right? Compute the map, right? See how many times we saw E, how many times we saw A, how many times we saw T, right? Right? And then I store that map somewhere, right? And then I check, right, for any other string that have the same, right? The same frequency map as another string, right? We know that those two belong together, right? And then we're gonna group them by that, right? So if different words in the list, right, they have the same frequency map, then we know that those are anagram of each other because they have the same characters, right? And at the same frequency, which is exactly what we need. Just like we did in the other problem, right? We compared the frequency map. That's how we're able to know if two strings or anagrams are not of each other, right? So probably saying, how do we store maps, right? We're not gonna store a map. We're gonna store the serialized version of the map, right? So we will compute the map and then serialize it, right? So what we would do is we'll have a frequency map, right? Which would be contain the frequency of all the characters of in the string, right? For each word, right? Okay, so for example, right, we have we would have frequency map, right? So pretty much a map of 26 characters, right? Right. So and for the first index will be A, and the last index is going to be Z, right? So we have this array of size 26 that represents the 26 characters, right? And then what we're going to do with that, right, is to build the frequency map of each string, right? For example, right? So for A would be 1, right? Then we go to E, it would be 1 as well. And then we go to T. We get the 0 here with the Z, right, for the last index, right? Okay, so this would be the frequency map for this one, right? Okay, so we do that for each string, right? And then if for each string, right, we see that it has the same frequency map as another one, right? Then that's how we can easily group them by like that, guys, right? So for each string, right, for each word, we would build each frequency map, right? Then group each word that have the same frequency map, right? Because if they have the same frequency map, that means they have the same amount of characters. the same characters that are present in those strings at the same frequency, guys, right? It's kind of what we understand, right? So if they map out to the same thing, right, it must mean they're anagrams of each other, right? Different permutations or whatever, it doesn't matter, but they're anagrams, right? They contain the same characters and at the same frequency, right? That's what it can tell us by comparing two different. I think we did a problem similar to that, which was we were comparing, right? If words were anagrams and then we were comparing their frequency, right? Which is exactly what we're doing here, guys, right? So probably saying, how do we do that for each string, though, right? How do we keep track of that, right? So we're going to convert every map that we compute, right? We're going to convert into some sort of a string, guys. We're going to serialize it, and with that serialization, right, we could easily compare, right? Because easily group different anagrams, right, together, right? So you can see after, let's say we serialize it with this convention that we end up using, right? We end up putting each time, right, we encounter, for each count, we put a pound sign in front of it, right? And then we keep going with 0 for B, and then dot, 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 dot. Then you go to E, we put a 1, dot, 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 and then we put a 1 for T, and then dot, 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 all the way up to the last character, right? So pretty much we're taking all the characters, right, that are present, that are in the thing, right? All the characters in the map, right? And then we serialize it into this format, right? This convention, then we put it in our map, right? And then we can build our things like that, right? So that's how we can easily group them, all the different words that have the same anagrams, right? Group them together, right? So hopefully it makes sense to you guys. Let's quickly go into the code. I think it would make even more sense once we get into it, guys, right? So what we're going to do here, we have a map. We said that we can use a string here, right? Some strings. Hash map, right? What's going on today? Looks good. So far we have a map. So what we're going to do is going to loop through our string, a list of strings, right? So we got for each string, we're going to, so we decided we're going to go with this last, this one, right? So we're going to need a, we're going to need a, char frequency, right? Map, right? Okay, new int. And it's going to be of size 26 for the 26 letters in the alphabet. And then what we're going to do is simply build the map, right? And then we know how to build it because we did that in the other problem. If you guys are not familiar with this, please go check it out. Something should pop up. And then we're going to use our thing here. So for this character, minus the ASCII value, right, of A, right? We just increment it, plus, right? So we just do ASCII value subtraction, right, to get the index, right? So pretty much A minus A will be 0, so we'll compare the first one, right? And then B minus A will be 1, it will be the second spot, index 1, right? So that's how we can easily map that to that, right? So what's next for us to do now that we got our frequency map, right? Is to start building, is to serialize it, right? So we told you guys we're going to convert it into a string, right? Our whole map into a string, okay? Okay, after that, what we do, we're going to loop through the we're gonna loop it through it, right? So we're gonna be at count and char frequency, right? We're gonna serialize it. This be data append. We're gonna put a dot sign here, and then we're gonna append the actual count, right? So this is how we're serializing the map, right? And after we do that, we should be in good shape, right? We can get the key as be that to string. Then we're going to do a check here, guys. If the map does not contain that key already, if that key is not present, then we're going to go ahead and put allocate the list for it, right? So key array list. Okay. We're almost there. Then the lastly, not lastly. So we're gonna, so if after we put it in there, right, we get the key, right? For that key, add that word that maps to it, right? So we add that word to that list, right? After we compute the key for it, right? And all the different anagrams, since we have a uniform way of doing it, right? By having the map, right? The frequency map, and we serialize the frequency map, right, of each one of them. And if they map to the same one, then they'll be grouped together. That's kind of how we easily do that, right? And after to the end, right, we can return, right, your array list. Map that value, right? Okay, so if if two strings have the same, right? If strings have the same frequency map, right? It means that they're anagrams of each other, right? Because they have the same characters with the same frequency, right? So that's kind of how we can get away with this, right? It makes sense. So hopefully it makes sense to you guys. Let's press one go see the test case or else press submit. Awesome, guys. We're pass all the test cases, guys. All right, if you guys found value, guys, understood the thought process, let me know in the comment section. If you're new here, be sure to subscribe because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.